And welcome back. As we continue looking how late binding works in Java, particularly let's go ahead and use this with the toString and how that kind of affects some of the things that we may actually expect within our program. So when we look at the toString method here, recall that the methods equals and toString, these are a little bit different. They're special, and if we have an appropriate toString method in the definition of class, we can technically output an object of the class using system.out.println. The following, of course, is an example, and it would work because sale has a suitable toString method. A sale equals a new sale, tire gauge 9.95, system.out.println, a sale. This, of course, would produce the following screen input: tire gauge, price, and total cost equals $9.95. And again, this is because of late binding. It's nothing, we have to do. It's how Java does things automatically for us. Now, println is very, very powerful here in how we can use this, because the method invocation of system.out.println a sale is an invocation of the method println with the calling object system.out. One definition of the method println has a single argument of type object. The definition is equivalent to the following: public void println object the object system.out.println the object.toString. The invocation of the method println inside the braces is a different overloaded definition of the method println. That invocation inside the braces uses a method println that has a parameter of type string, not a parameter of type object. So when we start asking about this println definition within our own classes here, if you think about, println was given before the definition of how we define toString within sale. Yet the invocation of system.out.println a sale with that argument a sale of type sale, and henceforth a type object, it's in the definition of toString in the class sale that is used, not the definition of toString in the class object. Late binding is again what makes this work. So we're going to see late binding a lot here. Now, there is a kind of a caveat here, in which late binding doesn't exist for static methods. Java does not use late binding with either a private method, a method that has been marked as final, or with a static method. With private methods and final methods, this is not really an issue, because dynamic binding would serve no purpose, because again, if it's a private method, that's kind of restricted to within inside that class, or something where an outside programmer can't get to it anyways. And final methods, there's no way to take those into a derived class to begin with. However, with static methods, it can make a difference when the static method is invoked using a calling object. And that's going to take us to kind of our last little thing to talk about today, which is how late binding in Java is executed. When Java, or really kind of any other programming language that uses late binding, or does not use late binding rather, it's using what's known as static binding. With static binding, the decision of which definition of a method to use with the calling object is made therefore at compile time based upon the type of variable naming the object. And we look at our demo here, we're going to see the effect of static binding on a static method. And note that the static method announcement in the class sale has its definition overridden in the derived class discount sale. However, when an object of type discount sale is named by a variable of type sale, is the definition announcement is in class sale that is used, not the definition of the announcement in the class discount sale. So let's pop over our code and go see this. Alright, so if we look at our static methods demo here, we can have sale.announcement and we have discount sale.announcement. And of course, this is going to show the overriding of it. And then we're going to create a sale object here. And we're going to go ahead and from there create our discount sale object and then redo the announcements. And you see it'll say no surprise there. So let's just go ahead and run this so we can see. Alright, and what we'll notice is that these, of course, it says no surprise there. Alright, boom. Now we're changing sale discount to equal discount. Now if you notice, discount is what type here? It is a discount sale type. And that's where things get interesting. Because because the discount sale object in a sale variable, it's saying, what definition are we going to use? Well, it's using the sale version. Because even though this is using discount sales definition here, this type of this variable, so we always look at the type here, is going to determine which definition gets used. So this is because, again, if we look at the actual announcement class here. So I'm just going to pull that, or that method. So I'm going to go find announcement here. If you look at it, this is public static void. So it's a static modifier here on each of these. You notice some of these other methods don't have that static modifier. So like, for example, public double bill does not have that static modifier. And that is one of the things that happens with static, besides having different ways that we can call and use methods. But you notice with the static modifier here, that's going to go ahead and change a couple things. And we can see how that modifier is, of course, used here in this announcement as well. So it's just one more thing for us to kind of look at when we start looking at how late binding gets used within Java.